Gears. Introduction to gear. Gears use no intermediate link or connector and transmit motion by direct contact. The two mating bodies have either a rolling or a sliding motion along the tangent at the point of contact. No motion is possible along the common normal as that will either break the contact or cause one body to penetrate into the other. Assuming point P on either gear 1 or gear 2, the linear peripheral velocity is given by Pp is equal to omega 2 R2 is equal to omega 1 R1. The relationship between angular velocity, radial speed in RPM and the number of teeth is omega 1 by omega 2 is equal to R2 by R1 is equal to N1 by N2 is equal to T2 by T1. Angular velocity omega is equal to 2 pi n by 60. A gear drive is considered a positive drive because no slip occurs during its motion. Classification of gear. Parallel shafts, spur gears. These have straight teeth parallel to the axis of rotation. They are not subjected to axial thrust due to tooth load. At the time of engagement, contact extends across the entire tooth width along a line parallel to the axis line contact. This results in sudden load application, high impact stresses, and noise at high speeds. Spur rack and pinion. A special case of a spur gear where the rack has an infinite diameter, making the pitch surface plane. This combination converts rotary motion into translatory motion or vice versa. Example, lathe saddle movement. Helical gears. Teeth are curved and inclined to the axis. Mating gears have the same helix angle but opposite hands. Engagement begins at the point on the leading edge, making load application gradual with lower impact stress. They can be used at high velocity and have higher load capacity but introduce an unwanted end thrust along the axis. Double helical or herringbone gears, equivalent to a pair of helical gears secured together, one the right hand on the left hand helix to eliminate axial thrust. If the two inclinations meet at a common apex without a groove, it is called a herringbone gear. Intersecting shafts. Motion between intersecting shafts is kinematically equivalent to the rolling of two cones assuming no slipping. Straight bevel gears. Teeth are straight, radial to the point of intersection of the shaft axis, and vary in cross section throughout their length. Meter gears are a special case where the gears are of equal size and shafts intersect at 90 degrees. Spiral bevel gears. Teeth are curved and inclined, resulting in gradual load application, low impact stresses, and quiet operations widely used in automobile differentials. Zero bevel gears. Spiral bevel gears with curved teeth but a 0 degree spiral angles. Skew shafts, non-parallel, non-intersecting, uniform rotary motion is achieved through a combination of rolling and sliding action across generating hyperboloids. Shaft angle theta is equal to psi 1 plus psi 2. Cross helical gears limited to light loads commonly used for feed mechanisms on machine tools, camshafts, and oil pumps. Worm gears, a special case where the larger wheel's worm wheel has a concave shape and the smaller wheel's worm has a large spiral angles. It exhibits a very high sliding velocity. Velocity classification. Low velocity gear 0 to 3 meter per second peripheral velocity. Medium velocity gears 3 to 15 meter per second. High velocity gear greater than 15 meter per second. Gear terminology pitch circle. An imaginary circle where pure rolling motion yields the exact motion of the actual gear. These circles must touch each other for proper transmissions. Pitch point. The point of tangency of the two mating pitch circles. Pressure angle. The angle between the common normal at the point of tooth contact and the common tangent at the pitch point standard value are 14.5 degree, 20 degree, 25 degree. Module M. The ratio of pitch circle diameter to the number of teeth M is equal to dmm by t. Addendum. The radial distance from the pitch circle to the addendum circle standard value is 1 into m. Dedendum. The radial distance from the pitch circle to the root circle standard value is 1.157 into m. Clearance. The radial gap between the top of the tooth and the bottom of the mating tooth space clearance is equal to 0.157 mm. Circular pitch (PC). Distance along the pitch circle from a point on the on one tooth to the corresponding point on the next (PC) is equal to pi d by t. Diametral pitch (PD). Ratio of teeth to diameter (PD) is equal to t by d mm. Note that PC into PD is equal to pi. Backlash. The difference between tooth space width and tooth thickness along the pitch circle provided to prevent jamming due to thermal expansion. Law of gearing and sliding. To maintain a constant angular velocity ratio, the common normal at the point of contact of the two mating teeth must always pass through the pitch point. Velocity of sliding omega 1 plus omega 2 into Pc, where Pc is the distance between the pitch point and the actual point of contact. Tooth profile. Involute profile generated by a point on a taut tangent line rolling off a base circle without slipping. The radius of the base circle is the fundamental and unchangeable r base is equal to r into cos psi. Path of contact POC root over of r square minus r square cos square phi plus root over of r a square minus r square cos square phi minus r plus r into sin phi. Arc of contact, path of contact by cos phi, contact ratio, arc of contact by circular pitch, cycloidal profiles formed by rolling circles on another circle circumference. The face are epicycloid and the flanks are hypocycloids. It does not experience interference but requires strict center distance alignment compared to involutes. Helical and worm formula. Normal pitch Pn is equal to P cos helical center distance is equal to Mn by 2 T1 by cos phi 1 plus T2 by cos phi 2. Worm efficiency tan lambda by tan lambda plus phi. Maximum worm efficiency eta max 1 minus sin phi by 1 plus sin phi.